Use or not.
Oh, that's all right. We'll just have to do it all in our brain. Hi. Hello.
It's like the worst possible
Courtney.
place.
My name's Courtney.
Janelle.
Yes. I answered many names. Hey, you. Old lady, whatever. What's on your shirt?
It's my NSTA shirt from college
Oh,
that I thought was my most fitting shirt.
Ah.
Yeah.
Ah, yes, scientist, teacher. I like it. I like it.
See this one?
I like it.
What do you?
My daughter got this one for me.
Mine today is my brand new Planetary Society shirt.
Oh, cool.
I figured they gave us money, I should join.
Yeah, there's some
So I
merit in
did,
that. It's a
and,
unique thing. Well, see, I got mine. It says,
Johnny?
I need my space.
I figured, I could use this as a Halloween costume. Next time I can go as the solar
yeah.
system.
Good. This is
Or you
Courtney,
could just-
guys. Courtney, hi.
Courtney.
Hi.
And I know you. We survived Washburn together.
Barely, but yeah, I enjoyed myself.
Yeah, it's fun. But I just not forgotten half of what I had. 2/3 of what I had, but we managed. See what this is?
Yeah, that's a good one.
This is actually, at first I thought it was a laser pointer, but it's actually a little,
telescope.
yeah, my son gave me it, which is unusual. Lord Almighty.
I'm just saying, I'm sorry.
I'm saying you're being so intense.
I'm from Kansas City, but I got a degree in Emporia. I'm
Mm.
a planetarium there.
Oh, sweet.
Yeah, we remember when we went down there right after they had done that.
There's a planetarium in Emporia?
Yeah, at the university.
So you knew Susie? Or met Susie?
She was
No,
the
this
one
has
who
been
gave
a
me
while
the-
back, so it would have been.
The original redo?
Yes.
Okay.
They had another redo?
Yeah, there was an upgrade. There was no flood this time.
Oh, yeah, I
It
was gonna
just an
say.
upgrade.
That's, I'm gonna take this off. My asthma's bad enough. Well, the one at Washburn, their planetarium, they still had the scopes on top. They had and the software and the equipment died, and they haven't got anybody to replace it.
So they never get enough money to
Mhm.
put in a new one.
I was gonna be excited to make a decision if I could.
The digitals are a lot cheaper.
Okay. All right, I'll be right back.
Well, heck, you can get the little almost on the table things that do pretty good.
I'm saving up money to get one of those.
Uh-huh.
I mean, I'm a teacher right now, but.
Then we used to do, who was
You
that
keep
lady
bringing up
that you just
teacher,
kicked
every
out of
time
the
Wayne
room?
is coming.
She's going back. That's
There was a reason.
That's not right. It's
What's her
not.
name? Oh, that's a good name. Of course, when John was teaching, my late husband was a teacher, he'd say, "Oh yeah, what's going on with you, sunshine?" And he didn't mean that in a funny way. Of course, he was big enough, he loomed over the high schoolers. So.
I remember.
He didn't-
I never had much contact with John, actually.
Yeah, well, it could be good. They could use paddles back in your old day.
Hey, I got I did too.
Tell
Father
her.
Santa.
Me
Oh,
too.
Santa, yeah, he wasn't, John was the one who could really do, my husband was just built big, and when he took that ping pong paddle, he told me about it, he was rather proud. This one kid, they had a rule you couldn't chew gum in the end, this was when they were down on 8th Street. And this kid did it, he told him a couple times before, and he didn't, so he gave him some money and sent him down to the Walgreens or something down there in Kansas and said, go buy a pack of gum. So the kid comes back, and he said, now chew it all. So he did. And after it was there, he said, now we're going to go back in the closet, which is where they administered that thing. And he had him put that whole big wad on his backside, and then he took his ping pong paddle and let him have it. I know that story, he told it many times.
Sure, you guys got the ping pong paddle. I got the heavy wood, 3/4 inch wood
Oh, yeah.
with the holes drilled in, so
Yes.
there's no air
I remember that.
to block that.
Air resistance, yeah, well, that was probably Santa. wasn't
It was
Yeah, he was the master.
Increases the paddle velocity.
Yes, yes.
Absolutely.
I remember
Well,
that.
this was the guy that we're talking about with the paddle and everything. He was really thin, but he saw himself as a boxer.
Hmm.
He was
That's
a
why
priest,
I
actually.
thought I would go into physics, because that's a
Wind
pretty
resistance, that sounds
rule.
interesting.
Is this your first meeting, Courtney?
Yeah.
Yes.
Yeah, I didn't remember this existed for a while.
We're here.
Yes, well,
I've been here a couple months, but.
oh yeah. Well, COVID has messed up a lot of things. We're just kind of coming out of that now.
Yeah.
So that's a good thing. Speaking of things I can't find in my pile of papers, May 10th,
9th, wasn't it?
I don't know, that's what I'm asking. Ninth
For
or tenth?
the sort of open
Yeah, that's
house
this-
general.
Well, yeah, just the kind of general, how do we start after COVID
Whatever
meeting?
Saturday that is.
It's Tuesday.
Oh,
May 9th is a
Tuesday.
Monday, so do you want to go with the 10th? I put the 9th down
I
here,
put the
but,
10th down, and what, which one is
You wanna
it?
go with the 10th?
I don't know.
Tuesday's the 10th.
I mean, honestly, that's finals week for us, so I'm not,
You don't have a thing to do, do
well, I
you?
got a lot to do, it's just not, you know.
Mandatory. Yeah, I had it written down as the 10th, and then I didn't have time or place,
Well, we can
so.
change it to the 10th. I have not sent out the, and I also never designated a time. I don't think we ever talked about
And I
that.
was looking over the one you're thinking about sending the membership, and there's a couple things we might want to think about, tweak. I don't know which we should do first, them or us, though, really.
Yeah. And I have not sent anything.
Yeah, I know, but I mean, no.
But
I just don't know. I don't know in general.
yeah.
You can tell how organized I am. I'm only about 3 months past on a haircut. God, I got out of the shower and looked at it today, and I thought, my Lord, where's my pointy black hat? Dang,
Me too, it's getting pretty long.
I know, you gotta do something about that, Gary. I don't know how you get your hat on.
Yeah.
Have you ever heard of the?
Mine's getting a little out of control.
Yeah, I know.
Okay, so you can have
Yeah,
that
that one.
tonight for you.
Yeah.
I have these printed
You
out.
know if Dave's coming?
You can
I
have
don't
them.
know, I haven't heard.
I would like one.
Well, I would have thought he'd be here, but
Yeah.
Would you like to?
Should we wait a
It's
little
a whole
while
book
longer?
of them?
I don't know, it's fine.
Did you make that, Russ?
We could probably just get
I
started with the
printed
light
it, yeah.
stuff. and let
Where'd you get the info on it?
Okay.
You could download it.
Then we can wait for
Really?
the-
Yeah, send me the link on that if you would. Not right now, oh, whenever it's convenient.
And then we could all stare when he comes in.
Give him the hairy eyeball.
Yeah,
Well,
that's something we ought to have in loose leaf or something out. You know, you can put them up and say, here's what you can see tonight or whatever.
All right, so we go ahead and get started, I guess. We
I guess
get,
it's,
few-
everybody's probably out enjoying the fact that they can get out.
Yeah.
Yeah, this we usually have more. Hi, you're back. Hello, sunshine.
Hello, I'm back.
Yes, I know, well, that's
Okay.
something that we used to say to people, hello, sunshine, but in your case,
It's the actual name.
It's actually me.
yes, well, good to see ya.
Okay, well, anyhow, welcome everybody to the April meeting.
Are we online for this?
Shall we go ahead and, I know we usually do this, but should we go ahead and introduce ourselves just because we do have
Have
a
some,
new arrival? So, my name is Doug Gooding. Who wants to go next?
well, you can say you're the president and
Oh.
responsible for all things financial.
I'm the president, but not responsible for all things financial. In fact, I explicitly reject any financial responsibility whatsoever. So actually, I think I just got a text from Dave.
Oh, I think he's just saying you
Oh,
can
he's-
start without him.
Oh, okay. So also, welcome to those of you that are at home. All right, so my name's Doug Gooden. I am the president. I am not responsible for finances. I am responsible for, well, nothing else really. Running
Well,
the
but we
meeting.
can change that at this little pseudo meeting. We can fix that
Okay.
real good.
Anyway, who wants to go next?
Russell Valentine, currently making it so that people can see this online if they want.
Okay, very good.
Real.
I am Courtney. I am a person
Yes.
who likes space, and I really miss it since college. So
Oh, yeah. Did you get a degree from Emporia?
no, COVID hit, and I couldn't
Oh.
do my student teaching, and now I'm supporting myself.
Mm-hmm. What would you have been student teaching in?
Physics and earth science.
Oh, what level?
High school. I mean, whenever I was in high school, it was senior and freshman classes. So
Mm-hmm.
opening and closing of the high school.
Is Jim Aber still there?
He is technically still there. He retired, but he still keeps coming back because he doesn't know how to retire.
Mm-hmm.
I took
Excellent
the
question.
field geology class. The first semester he did not do it, so I didn't go with him. But his wife was the one that ran the planetarium and got it all up and going, and the one that hired me.
Interesting.
Cool.
I knew him, I know him slightly. His son did his master's degree in our department, so.
Oh, nice.
Jeremy.
I've heard about their kids a lot. I spent a lot of time with those two.
Yeah, I always liked, I liked both of them from the little time I spent with them. Anyway, well, welcome, and we're glad you're here.
I'm Tony Castaneda. Well, been here off and on for so started recently making a comeback. I'm trying to get there.
I am Sunshine Castaneda, Tony's wife. I'm just here for the ride.
She supports me in all of the different things. that I do.
Then
likes
she
to
is
come
one that
along.
we love and show our eternal gratitude to. Yes.
Exactly.
Now, I'm Gary Hogg. I've been here for about 1 million years or so. Been doing
Probably
a lot
close
of
to a
stuff
million
with
and a half by now.
Yeah, about 1 million.
Yes,
Change
okay.
at least, yeah.
Dinosaurs, wrote the dinosaurs, did and stuff.
Yeah, they're hell on those.
Yeah, they're pretty-
Anything
they're pretty-
based those
You have
dogs.
to watch the
didn't do
side
it.
steps.
I know, you had to watch them. I'm Jan/Janelle Burgard. I've been around longer than anybody except Gary, now that I think about it. And I like to I'm kind of the outreach person, especially kids. Tony saw that
She does a
first.
great job.
Yes, okay. But,
Some you
yeah.
can borrow.
What?
So we've got some you can borrow.
Practice all the time.
Yeah.
I have a grandson who's turning 9 this weekend, and the other one is in high school, so.
We've got from 21 to almost 4.
It's a wide range.
Yeah.
It's a wide range.
Yeah, well, John's got
So
Yes, well, no, I do a lot of outreach, and I do have sort of a way with kids. They sort of realize I'm just a tall kid.
I have a way with kids. I get around when they run away. Can we dim at least some of the lights so the screen looks a little bit clearer? So, a couple things then before we kind of get started. First of all, just a reminder of some upcoming events that we've got. Here, of course, is our homepage. You know about the general meeting because you're here. Next public night is May the 21st. Next general meeting is May 26th. Pretty sure I'll be here for that one. And then you can see some of the upcoming events here. So, one thing I did want to kind of mention today was something that we talked about at the last board meeting, and I'm soon going to send out a sort of a general message to the membership here, but we're planning for a sort of a members open forum. And the idea behind this, I guess, will be, and those of you on the board, if you want to chime in on this if I'm not getting it right. Well, the plan is to kind of have a discussion with all the membership about maybe club priorities, club directions, making the club schedule what what people want out of this. And we've got not a particularly big club, but in my estimation, a really diverse one in the sense that we've got people with very wide range of interests. And so we want to try to make club events as relevant as possible to the members. And so we're planning on doing this, and I guess I had the wrong date down. I'm told now we were discussing May the 10th. I don't think we've settled on a time. This will be by a strictly online thing. This will not be, there'll be no in-person meeting, so we'll set up some sort of a online forum for this. And we would really like for everyone who can attend to attend and provide us with some input. You know, those of us on the board, we kind of talk to each other, but we've sort of felt like maybe we need input to.
Yeah, and the thing is too, that we're kind of restarting, after COVID, because everything in the world just kind of went. And so it's kind of like, well, let's just kind of restart, with the different membership changes over time, and just kind of get everybody back in the swing of it a little bit. I think is a good thing good way to look at it.
And I think maybe just trying to get a little bit more involvement, get people more involved and find out, what it is that would entice them to become a little bit more involved in club activities. So
Yeah.
I hope that you can plan to attend that. I have not, by the way, designated a time for this. I was thinking probably sometime in the early evening, 6 to 7-ish, somewhere in there. Does anybody have any thoughts on that?
7-ish is probably about as early as people get finished with their.
I almost put 7 down as the
Yeah.
time, but then I thought, well, I don't know. I mean, I'm on a, particular eating schedule, so I'm usually done about then and usually ready for bed about 8:30, but,
Is the 4-year-old finished eating by 7?
We typically eat around 5:30,
Mhm.
5 or 5:30.
So
what day is the 10th on? What day is that?
that's a Tuesday.
Tuesday? Okay. So I can do, yeah, we can do 7. I usually pick him up from his mom's house about 7:30.
Mhm.
Okay.
Mhm.
But I can be coming right after that.
And any of you that are online, if you want to like send me an email or send it to somebody and kind of give us your thoughts on that, I'd appreciate hearing from you. Anything else that needs announcing?
I think so.
How are we doing with the Tomba? Is there any?
It's everything's way backed up, of course. I feel good now because my delay in getting things done is only a partial part of what's going on because everybody else has delayed their input. I'm actually making some progress on the mirror cell and getting that finished out. I've got about probably 20 hours of work, 25 hours of work in it now, and I probably have another 100 hours to finish it out. So it's a ways down the road, but it's making progress and things are coming along. I've got some pictures that I've been taking as I go. I want to document everything as I go. So, and one of these days I'll upload them.
Yeah, and for those of you that, and most of you I think probably already know this, but the club received over the past, 6 months or so, I guess, a couple of pretty sizable grants. One was to upgrade the mirror of the Tombaugh, which is our main telescope at the Farside Observatory site. Basically to make it a shorter focal length, faster, wider field of view, essentially. Also to make it a little bit more stable in the wind.
Less kite-like.
Yeah, because this right now it's a 27-inch Newtonian, and I'm not sure what the F is.
F5,
so
which means that it's sticking up
translates
in the
into
air about 14 feet.
very long, and so when it's in a roll-off structure, so when it's raised above the walls, if there's any wind at all, it shakes it pretty significantly. So this should take care of that. So that was one grant, and then another one from the Planetary Society to buy a new camera. So this is a much more capable camera that will really enhance the.
And it matches the faster focal ratio because it has a higher resolution.
Right. So once all this is done, it'll be a pretty substantial upgrade to the capabilities of that scope. So, I mean, we're really super looking forward to that. Anything else?
In our meeting Tuesday, I think the goals of what we want to accomplish Tuesday is really kind of define how we're going to approach like open houses and maybe even going out to other places and doing programs.
Right.
But just to give somebody a sense of what we're after here.
Right.
Yeah.
Yeah, and I mean, I can only speak for myself, but the main thing I would like on that is input, just getting people's thoughts on what they would like.
Yeah, and what would work for them? Because,
Right.
we set up a lot of this stuff, it was before COVID and before a lot of other things, and life goes on, so we have to kind of adapt. And so that would be, helpful too. And, everything from scheduling to, I was reading through what you had said earlier too, Russ, and the thing is, when we have people out there, we have fun. They have a good time, looking at stuff and everything, and of course I'm out there in the ooh-ah land anyway, but it's really, really cool, but you have to do it in a way that people can participate, so that's what we're kind of looking for.
You've probably never been out to Far Point yet, have you? Okay.
I've done Star Park.
Mhm.
Yeah, and it's what, near Eskridge?
Yes.
And it's
Reasonably dark. It's
Yeah.
a Area 3 zone. My observatory is in a 4. Yeah, of course, downtown Topeka's like a 7.
It
It's really horrible. But
took to one tower. Yeah.
It's dark enough that I've tripped over things, so
Yeah.
Yeah.
it's pretty dark. Of course, I've just been discovering lately that my eyes don't do quite as well at night as they once did, but I guess that's comes with the territory. Okay, few things. We, of course, we get the news from Jan every day, and I kind of look forward to that. That's usually something I do while I'm kind of settling into my day, as I read through these. But there was a few I thought were kind of interesting that I just wanted to kind of point out. And again, this is my totally personal view on what the big news is, so may not necessarily jive with others. But one of the things I thought was most interesting this past week or so, I guess, is the National Academy of Sciences Decadal Survey came out, which is National Academy of Sciences is a governing board, or not even a governing board, an advisory board that essentially was set up to provide expert scientific advice to the U.S. government in lots of different fields. And they do decadal surveys of almost all disciplines. Like there was a decadal survey in my discipline a couple of years ago, actually. And what they are trying to do is get input from the community on what the big priorities are. And it's actually kind of a big deal because a lot of times these are put into action. These are actually taken care of. So some of the things I thought was kind of interesting was that the big winners, the things that were really popular were in planetary science at least, was first of all a mission to Uranus. It's one of the major planets that's not had a dedicated mission to it. So that will probably happen. I mentioned Enceladus, which again is a kind of an interesting moon that planetary defense keeps popping up. And this is not like, setting up defenses against the Klingons or anything. This is defenses against asteroids, basically. And this is, of course, really interesting to us and to Gary and especially because a lot of the work that we do out of Farpoint is basically kind of helping to understand the orbits of things that could potentially hit the Earth. And something pretty big passed by, yesterday? That was a fairly large
Possibly.
thing that, I know.
The thing of it is, people ask me this all the time, because I've been doing asteroids for a lot of years, for like 2 decades. So, people ask me, did you see that one at King Bay? No, I didn't, because for one thing, it's not here. But you can't keep track of all of it. And I've got always incoming information about, things of near-Earth objects that are potentially hazardous and all that stuff comes in. So I get inundated with a lot of it. And most of the time, the thing that gets close to us are like, the size of a basketball. They're just not very big, or Volkswagen either one. But the Volkswagen will burn up in the atmosphere, so you may have a little bit of stray left over, but not much. The problem is that you get something big enough that gets close enough, and that should get attention. And
Yeah.
because it isn't as close as some of these smaller rocks, it doesn't get much attention. But those are the ones we really need to pay attention to, because the light of orbit shift on those could be a big problem next pass.
Yeah.
So that's really where I kind of concentrate. The small stuff is like, okay, you're going to get a nice meteor shower.
Well, I thought it was kind of funny, though, CNN, of course, which is, as a news source, has its flaws. But anyway, they described it as a giant asteroid, and there was probably, I don't know, about the size of a bus, probably, big enough that if it came to the atmosphere, it hit something, it could cause some pretty serious damage. But
yeah.
we're not talking about a life killer here, but
No.
I guess, headlines are headlines.
And keep in mind that most of the surface is not land anyway.
Right.
Right.
Yeah. So anyway,
Yeah.
but these are some of the things that were kind of the recommendations. So over the next decade or so, we're liable to start seeing some of these kind of put into play. This is one I thought was interesting because exoplanets or something just kind of fascinates me. Evidence of farming. I kind of what they were actually talking about here was, and this is not. My first thought was, you got to be kidding me. But what they're really talking about is the composition of the atmosphere, which
Which
changes
is what you're
due to-
working on, essentially.
Right.
That's
I mean, this is the guy that teaches this at K-State. So he knows of what he talks.
Yeah, and essentially what they're saying is, with the Webb, it might be possible to detect elements in atmospheres of exoplanets, which would be pretty clear indicators of a biosphere. And yeah, I think this stuff's really interesting. What always fascinates me about this is that the James Webb Space Telescope is set up to see in the far into the infrared part of the spectrum, the part of this infrared spectrum that's thermal energy, basically.
Yeah, right.
And most of the things that we look at, I spend my time looking back down at the Earth usually, and the areas that we're really interested in are really short wavelengths, to the point where, if you were trying to build an instrument to see from that far away, it would have to be monstrously huge. But so I'm curious to follow this, because I don't necessarily. I was a little surprised that they were able to, or they thought they'd be able to detect this at such long wavelengths. And then the Webb was kind of optimized for those long wavelengths, because it's designed to look at things very deep into space, deeply redshifted. So maybe redshifting enters into this, but anyway. So I thought this was kind of interesting. This was from the Physics Archive, if you're interested. This is a kind of a cool blog, actually.
And the other thing too is I just saw a few days ago that the testing on the James Webb is coming along beautifully.
Yeah, it's almost all done.
It's just, and it's just really hitting the markers. So that's, considering the complexity of that thing, that was good to hear.
I heard it referred to the other day as a $10 billion origami experiment.
That's mine. Sorry, guys.
So, same blog, radar measurements suggest Jupiter's moon Europa might have water near the surface. On the one hand, it's like, okay, there's water, but the thing that kind of always sets my radar off, no pun intended, when I see something like this is water, life. So this I think is kind of an interesting finding, because this could really be again another kind of indicator that there may be some kind of life on Europa.
Well, how many moons now are suspected to have water on their surface? Is Enceladus?
Yeah, I think,
Yeah,
Enceladus,
And then Europa and Titan is supposed to have some kind of.
Yeah.
yeah. I think Ganymede might have.
Ganymede, yeah.
I know Ganymede.
They're finding out that more of these, especially the ice crust ones, have a good chance of having stuff going on underneath.
Well, heck, they found it on Pluto. Actual water ice now there too, so it's a lot broader space than we originally thought.
Yeah, this is one I thought was pretty interesting. Anybody see this?
Oh,
One of the things that is became kind of a buzzword in a lot of sciences in the 90s and 2000s was visualization. The idea that kind of brought about by the fact that we have all these advanced tools for, graphical tools now. So, one of the things we teach our students these days is visualization, how to gather information just by looking at it. Well, now they have, they call them audizations or something like this. And this is one from the Chandra X-ray Observatory. You probably won't be here, Doug. So this is basically, this particular image, which is an X-ray image, turned into sound.
Sounds like they're playing the piano.
Well, I don't think
Sounds like a harp.
I don't think it's going to be performed in concert anytime real soon. But this is more than just kind of ooh, cool, we can make sounds. There's actually science involved in this.
Yeah.
So
I've seen several different ones now, and it's really interesting, because sometimes you'll be going along. It's just like when you see, when they're measuring something like solar flares or something that gets louder, and you go along there, and then the one that I can think of, and I can't remember who did it now, different elements were assigned different notes, and so they'd be scanning the sky, and they would, it was really interesting, because it would really all of a sudden vary, and it's an interesting way of looking at it. It's another way of thinking of it.
one of the first, and it had nothing to do with astronomy, but one of the first people I ever saw kind of turn nature into music was somebody that was out running one day, and he was looking at power lines, and they had birds on them, and he was a musician.
Oh, yeah.
And he thought, oh, those look like, hey, Dave. He thought, oh, those look like
Notes.
musical notes.
Yes.
So he went back and converted them into musical notes and actually made a song out of it. Anyway, this is, I thought this was pretty interesting. So, exoplanet outside the galaxy.
Yeah.
This was around an X-ray source, so this also came from that Chandler X-ray Observatory. I don't know, this is probably not a big surprise, but it just is kind of interesting. And again, discovering exoplanets used to be kind of a big deal. Now it's becoming almost a routine thing. But this is the first time outside an exoplanet outside the galaxy. And it's really just remarkable to me that, people are finding planets in other galaxies.
Yeah.
Just, I don't know, just really amazes me. And of course, we have the most distant galaxy yet found. So another kind of cosmic record set. Anyway, so those are some of the interesting things I thought happened. And by the way, if you've got something you think is interesting, you want to throw it into a meeting, just please feel free. Okay, so Jan, do you want to talk
Okay,
about
we go
Jim?
from the amazing things we're finding now to the history of what we look at in the sky. And we started doing this a while back, and so I picked Gemini, which is just about gone. But it's got some interesting, the mythology behind this one is really kind of interesting. Of course, I left my notes at home. But Gemini is Latin, and it means twins. And we probably all know that, and these are the twins. If you look at it in the way of the stars, it's Pollux and Castor, but it's usually said the other way. And their little symbols there. Pollux was supposed to be a big, great boxer, and Castor was he was really good at fencing. Why they put and I guess music too, and they were both very good horsemen. The interesting thing too to me is that because, as you can see in their heads there, those are the two bright stars, Pollux and Castor, and many civilizations identified those two as something. The ancient Egyptians thought it was twin peacocks, and I can't now remember who it was. The Greeks, I think, said it was not the Greeks, but Armenians said it was twin goats. And because they are so bright and they're kind of close together, they just stand out. And so it's interesting that different civilizations have put those two together as some sort of a twin. But this shows just kind of the drawing of how they fit in the general constellation. And yeah, go to the next one. And then this is actually what you would see on a star chart. And you can see Pollux and Castor up there, and these stars are all in the general outline, are bright enough that you can see it kind of comes down in the two lines. And you could say it has some stars out there. Some people will put from right there, they'll put that one on there. Some just kind of go straight down there in the straight line. But it's very bright. It is a constellation in the zodiac. It's the 30th largest constellation in the sky. The two main stars there, Pollux and Castor, they have an interesting little difference between them. If you notice on there, Castor, it was given the designation Alpha, which is usually given to the brightest star in the constellation. And Pollux is given Beta, but in actuality, Pollux is brighter than Castor. And as far as the stars are concerned, Pollux is an orange giant, and when you can see there is a difference in color just with your little naked eyeballs. And there they are right there. There's you can see that that's an orange, but Pollux is actually a sextuple system. There are 3 binary systems there in what did I do with that? Yeah, in Castor over here on the right. And it's because of that, the fact that they are, you have co-orbiting going on, it's considered, it's basically called to be a, when they quote it, they say it's like the 23rd brightest star, and then you'll see some people will give it a range of, say, about 1.9 to 2.1. but actually the visual magnitude of that one is stated as 1.58, whereas Pollux is given a magnitude of 1.5. 1.5, yeah, 1.5. And so that's stated, and it's the 17th brightest star, even though it has the designation of beta. And one of the reasons that they suspect that is because it could be that Castor was actually brighter when they were doing these assignments, but it's still variable enough that technically it is considered to be second in brightness to Pollux, but it was designated as alpha back then. So, you know, and when you look at the systems there, each one of them, there's 3 systems. Each one of them is a binary, and at least one of them it's eclipsing binary. So that would also affect some of the brightness of it. Okay, go ahead, next one. And then from more of a standard or an observing standpoint, you can see Castor's circled up there. And it's only got one Messier object in this constellation, and that's M35 down there. It's right off the foot of Castor. And I tell people, this is one of the things that help people remember, it almost looks like Castor is kicking it. You know, he's playing ball or something over there. And the 2 circle areas are in there. That's sort of a history of astronomy thing. That one right there, the Delta Geminorum, that area right there is where Clyde Tombaugh was looking when he discovered Pluto. And then at the Eta, down there by M35, that is where Uranus was originally discovered when it was first observed. So that's just a little historical aspect behind Gemini. And then those yellow lines are the actual outlines of the area of the constellation.
I assume that dashed line is the ecliptic?
Yes, it is. Yeah, that's the ecliptic. It's a constellation of the zodiac. And you can see right down on the lower bottom there's Betelgeuse, so it's just kind of a little above and to the one side of Orion. And it is in that, it's Pollux and Castor are part of, you hear it sometimes called, I've heard it called the winter snowball, or the winter football, and some other things, because there's about 7 stars that are real bright that all kind of form a circle in the winter. And those 2 are a part of it. So that's what we have to say about Gemini. Oh wait, I forgot the good part. The mythology. Okay.
Do we want to go back?
Nope, that's okay. I'll just say it because this is kind of R-rated. If you know anything about Greek and Greco-Roman mythology, the Greek came first and the Romans adapted a lot of their gods to the Greek myths. And Zeus was, how can you put what Zeus was? Zeus liked the ladies, let's just put it that way. And he was married to another goddess, Hera, who was jealous as all get out because she had reason to be. Anyway, the king and queen of Sparta were Leda and Tyrannius. And Leda and her husband got together, and then later that night, in the form of a swan, I think, Zeus came down and had his fun with Queen Leda also. So later, she gave birth to twins, actually 2 sets of twins. And the boys were Castor and Pollux. But Castor was the son of Tyndarus, her husband, so he was mortal. Pollux was immortal because he was fathered by Zeus. And their 2 sisters were Clytemnestra and Helen, as in Helen of Troy, and her father was Zeus. That's one of the reasons she was the most beautiful woman in the world, and we know where that led to. But anyway, these 2 were the twin brothers. They were considered to be extremely good horsemen. Castor was known as one who broke horses. He also was an expert at fencing and supposedly taught that to Hercules. Whereas Pollux, he was a boxer. He was, and that was kind of his thing. And being divine, it probably didn't hurt him any when he did that. But, of course, their sister was part of the start of the Trojan War. But anyway, they both had a lot of adventures. They went looking for the Golden Fleece, and they were in the Trojan War and whatnot. But eventually, human Castor died. And his brother was so upset about losing his, Pollux was so upset about losing his brother, he went to his father Zeus and asked if he couldn't somehow live forever. And so Zeus made them both immortal and put them up in the sky where they would never be apart again. And that's the myth of Gemini. So
Okay,
there.
Well done.
thank you.
The thing that's interesting about that is when I'm out at Bar Point, you tell that story, people remember things better. Especially when you talk about the he and the she and the gods and stuff like that. But it's one of the reasons I tell that. And, you know, sometimes it's in movies and whatnot. And it's also the history that has a lot to do with astronomy. So that's why I do that. All right.
Okay. All right, so what I'm gonna then kind of talk about here is something that makes me both interested and a little bit scared, because I'm going to try to demonstrate something live here, and this could work and it could just go massively off the rails. So I just want to kind of, you know, warn you ahead of time that I did practice, but, you know, things can always go wrong. So what I want to talk about is basically something that I've been kind of playing around with lately, and I came at this title of, you know, what to do when it's cloudy, but there's really more to it than that, actually. You know, one of the things that I think makes astronomy interesting as a science, as an activity, is that it's really visual, right? You know, most of us probably, one of the primary things we like about it is going out and looking at these rather spectacular sights sometimes. And of course that usually involves looking through some kind of a telescope or something. And I think in some ways that's probably what was at least the initial attraction for a lot of us. It was just the visual aspect of it. Of course, one of the other things that draws a lot of people to, and myself among them, to both, I guess, amateur and professional, is that it is a science that you can make a meaningful contribution to, a meaningful scientific contribution to. And that has actually expanded. It's been that way for quite a long period of time. I can remember when I was very young seeing an article about people who were meteor counters, and they would go out at night and lay in these things that look like coffins because it was cold, and count meteors. You know, so citizens have been making a contribution in various ways for quite a long period of time. This has gotten much, much easier. I mean, this is just a picture I found on a real estate site, actually. There was a guy who lived, I believe, in Vermont, trying to sell his house, and he had his own observatory, and here's a picture of that. And I was kind of struck by this because, you know, this particular setup right here is obviously very impressive. And maybe 30 years ago, this might have been the kind of thing that would only have been available to maybe universities and that sort of thing. But now, this kind of thing can be owned by private citizens. And the thing that's been most impressive to me is the improvement of cameras. I mean, telescopes and the optics, I think they've gotten better, or at least less expensive. I don't know, maybe better is not the right word, but they've probably gotten a little more affordable. But what's really been impressive is cameras, and particularly CCD technology, you know, which is, in my professional career, has gone from something, you know, exotic, you know, a CCD costs tens of thousands of dollars, to something that, you know, every cell phone has one in it. And that's really opened up some avenues for astronomical citizen science, and a lot of people have taken advantage of that. One of those people is us, you know. So, you know, here we are. I don't know. These guys all look like they know what they're doing. This guy looks like he's permanently lost in the fog. But the work that
Looks like they all have just escaped.
But in the background, that's the tombaugh as it was.
Yep. So there's the tombaugh back
Yeah.
there. There's the camera that's being replaced. This tube is going to be about 60% as long as
Go
it is
that
now?
way a little more, the other way.
Yeah, less, yeah.
It's-
Yeah,
it's-
or less. Yeah.
Yeah.
Yeah, it's going to be smaller, shorter.
Much shorter, yeah.
But anyway, what's being done with this is, observations of minor planets and near Earth objects. There's kind of an example of one right there you can kind of see. So this is something that Gary and Dave have spent tremendous amounts of time doing. What are you up to in terms of numbers reported now?
Oh, you know Farpoint?
Well, Farpoint's 9,100, and he's pretty close to doubling that, I think.
So,
$16,000,
thousands of reports. And there's a whole bunch of people doing this kind of stuff. But this is the sort of thing you can only do with a CCD camera. You could not do this with film, I don't think, just because you couldn't advance the
And
film.
we're gonna switch that from a CCD camera to a CMOS
Yeah.
camera now.
So an electronic camera. So this is the sort of thing that is possible to do now. Of course, one of the things that's also interesting to me is variable stars, which are stars that get brighter and darker for a variety of different reasons. And this involves photometry. This involves the measurement of light, which again, when I was an undergraduate back in the 80s, photometry was difficult and almost dangerous, to be honest with you, because basically you had to use a cathode or photo multiplier tube,
Yes.
and they had to be kept really, really cold. And they weren't imagers; they were just light measures. They had to be kept really, really cold, which meant they had to have like liquid helium around them. I don't know if you ever worked with liquid helium, but it's nasty. And they had to have these power supplies. If you have accidentally touched the power supply, it could, shock you into next week. So there was just a lot of danger involved in these things. And now again, there's cameras that you can buy off the shelf. So this has been a real kind of boon to the astronomical research. One of the things again that I'm real interested in is exoplanets, and that's the same kind of deal. This guy right here, by the way, his name is Dennis Conti, who is the AAVSO, the American Association of Variable Star Observers, kind of head of the exoplanet division, I guess you could say, or the exoplanet interest group. And he's a hobbyist, he's not a professional astronomer, but and his setup here is a pretty modest rig, to be honest with you, and yet he's been able to make a tremendous contribution to the science of studying exoplanets just with very modest equipment. So, here's his rig, there's his camera right there. This is actually a book that he didn't write, but it's, there's books about this stuff now. And this actually is something I want to demonstrate here a little bit later. So again, this is I think just a wonderful example of the kind of thing that non-professionals are doing. But the one thing that all of this has in common is you got to have clear skies. And we know from experience here that we see this kind of thing pretty often. This is from what's that site called? The Clear Outside or something like this, and you can see total cloud obscuration. You go up and you look at this. And so what I thought I would do is talk a little bit about what you can do when this happens, or the kinds of things that don't rely on making your own observations, basically. And I suppose you could think of it as well, if it's a cloudy night, this is an alternative activity. But not everybody necessarily wants to make their own observations, or has access to the equipment to make their own observations, or wants to stay up all night. So when you look at pictures like this, Dennis with his telescope or us with our telescope, it's always the telescope. People are always posing next to the telescope. But the stuff that happens on the telescope is only part of the story. There's the collection of the data, and there's the reduction of the data. And it's not as kind of glamorous to pose next to your computer, but a lot of time gets spent on data reduction, on pounding away on the computers. And that, by the way, is also kind of revolutionized too, because computers that would have been state-of-the-art marvels back in the day are now, you can carry them around with you. So the ability to reduce the data has just progressed by leaps and bounds. And so that's actually what I want to talk about tonight. I know this is kind of a long lead up to this, but I want to talk about things that you can do if you're either not interested in observation, or you don't have access to observations, or if you just kind of want to make a contribution, but you don't want to spend huge amounts of time that it takes to do these sorts of things. And so there's a lot of interest in this out there. These are 3 sites that I found that kind of organize this sort of activity. One of the most interesting ones is this Space Hack site here. If you go look at, anybody ever seen this before? It does actually kind of, it's actually got a lot of different ways to participate in various kinds of space exploration. So this one, the Project Phaedra, I thought was real interesting because they're actually digitizing all of the old logbooks from Harvard College Observatory, the Harvard computers. You know, you might already know, those of you know a little astronomy history, you know the Harvard computers were women who basically computed things by hand, you know, and this was back before electronic computers were available. And so much of what we know about things like variable stars is the result of the work of this. So that's that's one of the things that is available, and you can make a contribution to, and there's a few other things here as well. So this is a way to kind of get into the door on this if you really want to participate. There's a few other things too. Galaxy Zoo is a site for classifying galaxies, you know, visual classification of galaxies. So you look at pictures and classify them. And SETI at home has been around for a long time. Basically what it does is it takes your computer and turns it into a giant, along with everybody else's, into this giant distributed computing machine to analyze SETI data. I don't know, is that still in business? I used to.
I think it is.
But anyway,
Yeah.
so these are ways that you could get involved without, you know, access to a lot of equipment. But if you want to actually work or participate in the data analysis, one of the real open doors right now is to work with data mining. So data mining is again kind of a consequence of big data now. You know, big data is the big buzzword everyone uses for almost any science now. And data mining is really just about finding patterns in data, learning and finding patterns. Data mining was when I first was exposed to it, was kind of a foreign concept to me because it's the opposite of the way I was taught to do research. You know, I was taught to do research by, you know, you think about your pattern and then you look for it, and this is more like you look for patterns and then you think about them. But it's become a very common activity now. And like any other source of data, any other science, astronomy has this issue of too much data or just tremendous amounts of data. You know, doing astronomy, doing modern science in general in many ways is like drinking out of a fire hose, trying to drink out of a fire hose.
Did you pose for that picture?
No, that's not me. I don't know who this is, but I use this picture a lot. And in fact, in my field, I make use of a lot of data that comes from orbital satellites. And one of the terms that's informally used sometimes for the volume of data that comes from one particular satellite we use, called the AROS satellite, which has about 11 instruments on it, is a lock, an LOC. And we think about a lock every 3 days. So we get a third of a lock of data. A lock is the amount of information in the Library of Congress. So we're talking about just a tremendous volume of information. And trying to make sense out of all that, as you can well imagine, is a pretty difficult task. And so, you know, scientists, being both smart and lazy, have often decide, hey, if we can get free labor to do this, let's do it. And that kind of opens up some opportunities, though, for people like me who, you know, just kind of like monkeying around with data, to make a really useful contribution. So as I said, or as I indicated, there's a lot of astronomical data sources out there right now. Here's a few of these. There's telescopic surveys, ground surveys. The Sloan Digital Sky Survey has been in business for, I don't know, 15 or 20 years now, I guess. So there's been quite a lot of ground data collected. The American Association of Variable Star Observers, the AAVSO, is a network of both professional and amateurs who contribute observations, and their observational database is huge. And then there are these space-based surveys, which are satellites that basically routinely collect data. They're kind of like the stuff we use, except instead of pointing down at the Earth, they're pointing out. So the Gaius, which was an astrometric satellite, kind of a positional satellite, used a lot in the work that Gary and Dave are doing. The Kepler satellite, which was designed to look for exoplanets, basically, which is inactivated now, but collected data for quite a number of years. And then the follow-on to Kepler, which was called TESS, which I believe stands for Transiting Exoplanet Survey Satellite. Same basic idea, except it sees a much bigger piece of the sky than Kepler does. And all of these are collecting data. Well, Kepler, it's no longer in working, but these are just routinely collecting data. To the point now where there are literally millions of observations. I mean, literally millions. You'll see how many there actually are right quick. And most of those have never been analyzed. So it creates a role for people who maybe have a computer and a little bit of curiosity. And as we're going to see, it takes a little bit of technical skill to do this, but it's not overwhelming. I can do it. So if I can do it, anyone can do it. And so that leads to the part that I've been kind of nervous about. I want to look at a hands-on example. So what I want to do is look for a planet. Now, I'll warn you ahead of time that I've done this a few times already and I've not found anything. So I'm not making any promises here. But we will run through one example that we know there's a planet there. And that'll kind of show you what one would look like if you found it. And then another example, we'll just pick one and see if we find anything. And again, no promises, we probably won't, but at least we'll see how this works. So there's a couple tools we're going to use. We're going to use some data. The new search, we're going to use test data, but the existing one, we're going to use a Kepler example. So we'll use data from both Kepler and TESS. The tools we're going to use are programming tools it's a script in Python. And I don't know if any of you have any kind of experience. I know you probably do. I'm about a C- D+ Python programmer, but I was able to cobble together using tutorials of various types, a very short script to kind of demonstrate this. So again, if I can do this, anyone can do it. Okay, so what we're going to be doing then is we're going to be looking for transiting exoplanet. So a transiting exoplanet is one that passes in front of its star. And as it passes in front of the star, there's a slight drop in brightness. And here's a video that kind of shows this. And the transit method is one of the ways that exoplanets are studied. So you can see it passes in front, there's this dip, and it makes a very distinctive looking shape in the light curve. So the basic idea here is that you measure the light curve, you look at the light curve, and if you see this real kind of distinctive dip here, that is at least some evidence that there might be a planet there. And that's the kind of thing that the people who are analyzing test data and Kepler data are looking for. And that's the kind of thing they want people to be looking for, because then you find a suspect, you could follow up on it, see if it really is an exoplanet. The thing about this, though, is that dip in brightness is not very big, right? There's a big star usually with a little tiny planet passing in front of it. So it takes a lot of photometric accuracy to actually do this. So those satellites are actually designed to do that. Okay, so I'm going to start by discovering a planet we already know about. So this was kind of a historical one. This is Kepler 8b. It was the very first planet, very first planet discovered by the Kepler telescope, or discovered with the Kepler telescope. So there it is, right there. This is some of the information about it. It's a little bit bigger than Jupiter, about 1.4 times bigger than Jupiter, about 188 times the mass of the Earth. So it's a pretty good-sized planet. It's also really close to its star and orbits it really fast, and that makes finding things a little easier. So this is the alternative names here. One of the alternative names we want to keep in mind is this one right here, KIC 69222244. That's the designation of it in the Kepler catalog, and we're going to need that number. So we'll keep that in mind. So what I'm going to do is I'm going to open up a Python tool. And by the way, I'm not a Mac user, and so I sometimes struggle with this. So if you do decide you want to work on this, what I would recommend that you do is download this thing called Anaconda, and in particular it has this tool called Anaconda Navigator. Anaconda is a kind of a set of tools basically that make it easy to work with in programming environments. And in particular, it loads a bunch of libraries and packages that you're going to need. There's loads a bunch you're not really going to need either. But it's particularly designed for science applications, so it's going to load some stuff that you kind of need. Python is what's called an object-oriented language, which means that it kind of organizes things around, I don't know exactly, how would you describe an object? Not exactly sure how to describe that. But anyway, and then it uses packages. And packages are basically just pre-created tools that you can use. So you don't actually have to write your own code. You can just use the code that's in the package. So that's what we're going to do. So I'm going to open up a development environment called Spider. You notice the PY trend here. You see that a lot. You know, Python, PY, Spider, Anaconda, numerous references to snakes when you start looking in Python. And so here's the little script that I put this script together almost entirely from tutorials that I found online. So this is not my original work at all. And so a couple things to kind of point out here. We're going to be using a tool called LightCurve, LightCurve with a K. LightCurve was actually a set of tools developed at JPL, at the Jet Propulsion Laboratory, and it was designed to work with TESS and Kepler data. And it was also designed very thoughtfully by the professional scientists who made it to be, a friendly package, and it is. And it was designed with the specific idea of it being used by non-professionals. So this is used by a lot of professionals, but it's also used by a lot of amateurs as well. So if you do decide you want to do this, one of the things you're going to have to do is load LightCurve. Anaconda does not load LightCurve. It doesn't contain it within the package. So you'll need to load LightCurve before you do this, but it's not particularly difficult to do. Okay, so first thing we're going to need to do is tell our script the tools that we need to use. And there's two tools that are not intrinsically part of Python. And one of them is called LightCurve, the thing we just did. The other is this thing called NumPy or NumPy, which is a set of tools that basically do numerical calculations. So we need to load both of those. So I'm going to run this a little bit at a time. And by the way, I also have, and again, if you ever want to do this, I also have created a thing called a notebook, Jupyter Notebook, which is a way to run this program without needing all this stuff. Basically, you run it in your browser. So there is a Jupyter Notebook version of this if you ever decide. I personally find Jupyter Notebooks a little awkward to work with. I guess I just kind of prefer this, so I'm just going to show you the basic code. So we're going to import a couple things here. So we'll designate those two lines and then run those, and they're loaded. So now basically what this is telling us is we can use LightCurve, and we aliased it. So this LK is an alias. So if we ever want to use it, we have to use LK as the alias. And then we alias NumPy as NP, kind of same idea. Okay, so the first thing we're going to do is download the data. So this line right here downloads the data. So we're going to download that Kepler 8b data set. Remember the Kepler catalog designation for it was KIC 6922244. So we entered all that here. The author of it is just Kepler. The quarter here refers to the quarter of the year in which it was imaged. So the data are divided up into quarters, and so this was from quarter 4. And then the cadence basically tells us that we want the longest, cadence equals long tells us we want the longest record we can get. because we're going to try to create a light curve, right? So we want a long time series of data in order to get an accurate light curve. So I'm going to go ahead and kind of highlight this line right here and run that baby. And so now we've created an object called TPF, which stands for, I believe, transiting planetary file was what I was thinking, or something like that. And it contains this set of images, basically, that include this particular star. By the way, this you can see this lk.search target pixel file. That's a command contained within light curve. So this lk says go to light curve, find this particular tool, run it with this bit of information, and then this little method at the end here, which is actually just a Python method, says download all that stuff, make an object, and call that object TPF. So that's what this whole command did. This is the sort of thing that I learned to program with Fortran, and you probably would have had to write 50 lines of code to do what this one line does. So I don't understand Python, but I kind of love it. Okay, so now we're going to look at a plot just to see what we got. So there's a number of frames. That's what the cadence equals long thing did. It says give me all the frames. So I picked one frame at random. I picked frame number 42 because 42 is the answer to life, the universe, and everything, right? So I picked the 42nd frame. You can pick any frame you want. And what this is going to do then is display the 42nd frame in color. That's what this line says to do. So we'll do that, and there it is. And one of the things you notice immediately here is that Kepler is a really blurry camera. It has really, really big pixels. And TESS is the same way. So you're not going to see a whole lot of detail in here, but there's a star right there. And that's what we're going to be going after here. Okay, this animate command has been frustrating me because this, according to the manual, I should be able to run this and create an animated thing that you can kind of scroll through all these, and so far it's not worked, and it still doesn't work. So I don't know what the problem is, but skipping. Anyway, that's what that's supposed to do. Okay, so now we have a plot. But the big thing we want to do is we want to figure out if there's a light. We want to look at the light curve because that's really what will tell us if there's a planet around it. So we're going to skip down to this section right here, all right, and we're going to create a light curve. So to do that, we're going to create another object. That object is going to be called LC for light curve. I don't have much of an imagination, so. And we're going to run a command called TPF to light curve that will create a light curve for us. It does, by the way, we are using an aperture mask here. And so what this is a digital version of, the masks that you sometimes put on optical telescopes, right, to kind of stop down things a little bit. And that's just to exclude the data that we don't want, basically. So this aperture mask is telling us to ignore all this crap right here and concentrate on the star we actually want. And by the way, again, I stole most of this stuff from directly from the light curve tutorials. So I didn't think of most of this, but so I'm going to go ahead and run these two commands. I'm going to run the light curve command, and I'm going to run then a command that's going to plot the light curve. So we'll go ahead and run those two guys, and there's our light curve. All right, can you see that okay? Mm-hmm. All right, so first of all, there's definitely something periodic going on there, right? You see every once in a while, boom, down, boom, down. So there's something, and it's very regular. So if we were just searching and we saw this, we would think, oh, there's something happening here that is a regular short period, short periodic signal there. And
That's
it's
a light curve of number 42?
No, that's a light. Yeah, that's a light curve of the entire series.
Oh, okay.
So number 42 is going to be in here somewhere.
Okay.
Right? Yeah, 42 is just one example.
Okay.
Think of this as like a stack of Tombaugh images, right? Taken one after another. So
Okay.
they're taken over a period of several days.
I thought you were, like, when you mentioned 42, I thought that was like a single,
It is a single frame, but it's just the one I picked.
okay.
They all look about the same. I mean, you can look at them and they look about the same because you can't really see the change. One of the other things to notice here is there's not much, even though there's this real periodic signal here, it's not dipping very much. If you look at the scale over here, this is flux in electrons per second. And it's a difference between about, 42,700 and 42,000 or 43,300. It's not very big. And that's actually good if you're looking for exos, right? Because exos are not going to dim the planet very much. If this was a really big drop, then it might be an eclipsing binary or something like that. The other thing you notice is that there's a trend here, and then there's this little business right here. This trend probably, that trend could indicate an intrinsic dimming of the star, right? Maybe this is some kind of a periodic variable itself. The star is a variable and it's getting dimmer and then it'll get brighter. That's a possibility. Could be calibration issues with the satellite. This business right here is probably where these satellites have to track, right? So every once in a while it has to reposition, and that's probably what caused that little business right there. But the trend here is kind of messy, and so it would be nice to get rid of it. The other thing is we might get a little bit better impression of the periodicity if we normalized all this a little bit. So what this next little block of commands does is it normalizes this signal. So it takes the biggest value and calls that 1, and then everything else is scaled to that. And so what it's going to do is it's going to flatten the line and normalize it. So let's do that. So the command we're going to run here is basically kind of LC, and then we'll call this flatten method right here, which is just basically flatten. The window length is long enough to include the entire time series. These are things that if you're doing this yourself, you probably would have to change. I actually asked it to return the trend, in other words, to return an equation that tells me how much dimmer it's getting, but I didn't really use it for anything. So this is going to return the flattened curve and the trend. And we could look at the trend if you wanted to, but I didn't actually use it for anything. So, and then it's going to plot all that on a new set of axes. So let's go ahead and do that.
What's the time duration on your light curve there?
This is days down here. So it goes from Julian day, maybe 350 up to about 450. So we're looking at about 100 days of data here. And so there's our curve flattened. You see it's normalized to 1. You see all the noise there, and then there's that periodic signal. So again, this is kind of, if we were just doing this de novo, we would be pretty excited, I think. We've got a very short time period, very slight dimming, and it's very regular. So that, those kinds of things might add up to an exo. So if we look at the time duration here, I don't know, that's maybe 5 days or so. And if you go back and look at the information that we got on the, what did we do with that?
It's in your presentation, wasn't it?
Is it in the presentation? Oh yeah, there we go. If we look at, go back and look at what we know about Kepler 8b, its period is on here somewhere.
3.5?
3.5, yeah. Where is that?
Down.
Keep going, halfway down.
There.
Oh, there we go. Orbital period, 3.5225 days. So yeah, I mean, we've discovered something that already exists, but we're pretty sure that's what it is. So we might actually want to know what its period really is, though. And so the next block of commands does that. So this is where you get into a little bit of technical stuff here. We're going to figure out the periodicity by fitting a function to it. And the function is something called box least squares. So if you've ever done like regression analysis, for example, where you actually fit a model to something, the mathematical technique that fits that model is usually something called least squares. It's basically minimizes the distance between each data point and some function. And in most regression models, the something, that function is a line or a curve. What the function is for box least squares is a little bit more, complicated. It's, as the name would suggest, it's kind of a box. So here's what the box least squares function actually looks like. And so what it's basically doing is it's assuming a signal that looks something like that and then trying to fit this to the data. And what we want to know is the period, right? The time between the minimum points on this. So that's what this box least squares command is going to do for us. And box least squares is actually a function in NumPy. So that's why we had to go ahead and load that NumPy thing there. So you can see this period command np.linspace. This is basically going to create a kind of a space for this problem to solve itself in. And we're calling that from NumPy. That's what the NP business there means. And then we're going to create what's called a periodogram. So let's go ahead and do that. So there's our periodogram, and what a periodogram basically is it gives you the power associated with periods at various intervals. These are really common tools for analyzing almost any kind of time series of data. For example, sunspots are analyzed using periodograms to kind of know the timing on those. And this is telling us that, there's a few periodicities in there. There's a really big one right there at about 3.5 days, which is exactly where we would expect it to be. So this would be pretty strong evidence if you were just running this, that there's something there and that its periodic signal is about 3.5. One of the things I'm trying to figure out is usually with periodicity there's a power level that's considered significant. So in other words, there's a level that peak has to get to before you can really consider it to be signal. And I'm not sure exactly with the BLS power how to calculate that. I know how to do it for like Fourier analysis and things like that. But and so normally you would get kind of a horizontal line there that would tell you if you exceeded that threshold. But this one, it's a pretty big peak there. So probably there's something there. So again, we might want to know exactly what that is. And the technique to do that is called folding, because if you can imagine that that time series of peaks, right? If you folded those over so all those peaks start lining up with each other, the amount you'd have to fold would be the period, right? And so this technique of folding kind of does that mathematically for you, and it'll tell you exactly what that period is. So let's go ahead and do that. And so basically what we're going to do is create a plot that will do this folding. So we'll go ahead and run that, and there it is. And so there we go. There we have a pretty good picture of that transiting exoplanet, right? So it passes in front of the star gets a little bit dimmer. You can see the flux difference is not very much, 8/1000th, right? 0.008. So it's a really, really small dip in brightness. But it has the classic sort of U shape that we associate with a transiting exoplanet. This particular shape would actually probably suggest that not only is it transiting it, but it's transiting it probably just about across the equator of the star. If they get a little higher or a little lower, that alters the shape of that bottom of that, so they get more U-shaped or less U-shaped depending on the timing of that thing going across there. And people that understand that can take a curve like this and tell you how big the planet is. They can tell you a lot about its properties just on the shape of this curve right here. So you can see this would be pretty useful information for professionals and anybody for that matter. So that is an example of discovering a planet that we already know is there. So, do you want to go ahead and try to discover one that is it? I mean, do you think we got enough time?
Sure.
That is a little bit more complicated because, we don't really know what we're looking for. So what we're going to do for that is we're going to look at some test data. So I'm going to go to a site called MAST, which is the data portal for a lot of orbiting satellites. So MAST, I believe, is Being pretty slow here. Yeah, there we go. So it's the Barbara A. Mikulski Archive for Space Telescopes. Barbara Mikulski was a senator from, I believe, Maryland. And this is located at Johns Hopkins, which is in Maryland. So Johns Hopkins hosts the data archive for all this. The thing I remember about Barbara Mikulski was she passed a law that meant that buying the data for my dissertation went from $200 to $3,700. It's not like I'm bitter or anything, but anyway, but she really was a wonderful advocate, and I don't know if she's still alive or not. She's definitely not in the Senate anymore, but anyway, she was a great advocate for space science, so I probably shouldn't diss her, but you know. Anyway, so I'm going to go ahead and open up that, and then I'm also going to open up another tool which is actually inside of MAST, but it's easier just to get to it this way. This is called ExoMAST. So I'm going to open that baby up too. So we're going to search the MAST archive. So let's go to MAST catalogs. Then we're going to search the test CTL. So let's get that. And then we're going to do an advanced search. Boy, this thing is slow. Sorry about that. Hope nobody's got any place they need to be. Okay, so here's our MAST catalog. Remember I told you there's millions of observations? Well, this catalog alone contains 9,488,282 observations, the vast majority of which nobody has ever looked at. So that kind of tells you the value of all this. And of course, that's a stupidly large number of things to search. So we're gonna narrow things down a little bit. And I'm going to narrow it down based on two criteria. The first criteria I'm going to narrow it down on is the temperature of the star we're going to look for. So well, it's already been done. I'm going to go down here to TF, that's the effective temperature of the star, and make sure this is checked. And what that'll do is give us the ability to search by that. The other thing I'm going to narrow things down on is distance, because we don't want to look for things that are way far away. So I need to find the distance. Where did you go? There it is. So I'm going to go ahead. That one's not checked. So I'm going to go ahead and check that. So that's going to give us access to some search filters. So let's start with the temperature. So we'll go on down here, and you can filter by a lot of things. These magnitudes here, right, are photometric magnitudes. You can do it, but I'm going to do temperature. So right now it's set for a range of 2717 to 78,990. Unimaginably hot star. I'm going to try to restrict the search to red dwarfs for one particular reason. Red dwarfs have a tendency to have larger, closer exoplanets. So they're going to make more of a light curve, and they're going to transit a lot faster. And that's something that TESS is particularly well suited to pick up, is fast transitors. So range of a red dwarf is about 2,000 kelvins to maybe 3,500 kelvins. So we're going to restrict ourselves to that. And what that should tell us is, okay, now we're down to 1.2 million possibilities. So we cut it down quite a bit. Let's do some work with the distance. I think that's up here somewhere. Maybe not. All right, distance. No, there it is. It's last. So we're going out to 23,447.4082 parsecs. That's a long, long way. Let's see. Let's go from 1 to, I don't know, 20. Yeah, 20. So that basically what we're looking at here is a sphere that is 20 parsecs in radius. So that should cut things down considerably. So yeah, 1,000 records. So that's pretty manageable. So let's see what we got. Let's go ahead and search. And there's all our possibilities. So this is the 1,000 and so TESS observations, maybe, because not all these are actual observations that we have to search for. And if you want to kind of look through these, this is a first one here. You can see it. And if you want to look at this one, there it is. These are the frames. basically. So what we want to do is just start searching these objects. And probably the best place to start would be maybe right at the first one. So I'm going to switch the search here to mass observation by object name or RA declination, and then I'm going to pick the object name. So I'm just going to pick this dude out of here. I can copy that. All right, so let's copy that. Let's paste it up here. Paste that baby. And then this is from the test catalog. So we need to give it a designator that's TIC. Oops. TIC. Okay. And we can search. All right. Hey, we got a light curve. So yay. So if you see this little icon right here, it means that there's a test light curve available. So there's something we can actually look for. We can actually kind of preview it if you want. Just click on the little icon there. And I don't see much in that that's periodic. I mean, if I were doing this, I would say, you know what, that does not look very promising. But we can go ahead and go through this just to kind of demonstrate what you do at this point. I'm not sure what else we might want to, maybe we should try this one down here. So here's another one, test SPOC. Maybe we should look at that one. No time series there. This, by the way, is something I'm noticing is not that unusual. There's a lot of kind of inconsistencies in this data set. So anyway, let's go back to and we'll just do this one. I'm like, 99.9% sure there's nothing there to see, but we'll go again. So one more thing we need to check here, though, and we need to check to make sure that this light curve is actually associated with the object we think it's associated with, because there's a cone of observation, and so we want to make sure that we're not looking at the wrong thing. So if you scroll all the way over here, the distance displacement is 0, which means that you're exactly on the object. So whatever it is we're going to see, it's from that particular object. So now we need to download these data. I actually wrote a script to do, well, I tried this a couple of different ways. First of all, I just tried to write the same command that I used for the Kepler. So there's our LK search command, but with another object. And it didn't work. And apparently, according to all the people that have been doing this stuff for a while, that's really, really very common for it not to work. So here's another way of getting the data. This is a manual download. So what we first need to do is actually download the data. So if we go back to the site here, click on the little thing there, and let's go ahead and download this data set. So we're going to download it into a file called test download. And this is where the Macs baffle me, basically. I don't understand how they do paths very well. But let's go ahead and download that. So there it is. And you can see it comes downloaded as a zip file. So I believe I'm going to have to close out some stuff here to find my way around. We're going to find that thing in this folder and that folder. And it's this one right here. So you'll notice that it's a zip file, right? So all we need to do is double click on it and that'll unzip it. So there's our unzipped file right there. And if we open that thing up and then open that up, there's a couple of different files in here. And the one we want is actually this TP file. There's actually already an existing light curve, that LC file. And a lot of the community that's doing this sort of stuff now is working directly with these. But I don't know, I guess I've been kind of thinking more along the lines of this. And notice it's a FITS file, which is the real common file format that's used. So what we need to do is we need to find the path to this. And this is the thing where I'm still getting used to the Mac. So you need to designate that, and then do this, and copy the path. Right, so, and this will work very differently depending on what computer you're on. So this will be different. Then we want to go back to our script and paste that path into the manual download. So we're going to paste that sucker right. And you can see there's already a path in there because I was fiddling around with this one earlier. So we're gonna fiddle that right there, and we're gonna paste it, and there we go. See how it changed? Okay, so now we have a path to the data. We can go ahead and run that command like we did before. Again, there's probably much better ways of doing this. So now we've created the object, and we can look at frame 42 again if we want to. So there's frame 42. Looks a little different, right? And again, I wish I knew how to do the scroll, because the demonstrations I've seen, you can actually scroll through and see the changes. So we can do exactly the same steps we did before. Create the light curve and plot it. Not much going on there. That is a pretty boring start, to be honest with you. But we'll go ahead and do we'll go ahead and follow through just for the sake of completeness. And there's our flattened, which was pretty flat to begin with. So not much happening there. I bet you if we do the periodogram, it's basically going to be a periodogram of no periods. And yeah, I mean, there's nothing there. That's I wouldn't say random signal, but there's nothing periodic there. So this star doesn't have a planet. Even if it did have if it is a variable star, it varies on a time frame much longer than this several days that we've been talking about. But anyway, so that's how you would do that. If you want to save yourself a little bit of trouble, you can basically take the catalog designation, copy that, go to this exomess site here, paste it in, and it'll tell you if a planet's been found at that site. So no planet. And so if that would probably be the first thing you'd want to actually do. If you find if there's a planet there, then move on. But that's how you do it. Obviously, this is a real quick and dirty introduction to all of this, and in reality, in practice, there's some decisions that you have to make. You'll have to kind of optimize some of those parameters based on what you think you're going to see, but it's not overwhelmingly complicated. At least I don't think it is. So how can you participate in all this? I mean, it's fun to do this just for grins, but I think most of us would probably like to feel like we want to report these data the same way that the NEO data gets reported or the variable star data gets reported. So there's a couple different ways of doing that. This is actually a project that NASA sponsored, which incorporates amateur participation into analyzing test data. So you can get involved in this. This, by the way, also is a place where if you're doing original observations, if you're actually doing your own photometry and you want to submit light curves of transits, this is a place you can do that as well. But you can submit transits to this. You have to present them in a somewhat different way in order to do that. You can't send in one of those phase plots. It actually has to be the light curve plot. But it's the same basic idea. So that's one way. Another way, and this is actually kind of a more general way, is you can get involved in the AAVSO data mining group. There's a group there's an interest group within the American Association of Variable Star Observers that is specifically about data mining, and they do a lot of data mining of the AAVSO archives using their own tools. But there's a group there that's doing this sort of thing as well, and it's a great source of information and a great place to kind of get involved with people who are doing these sorts of things, and a good way to make a contribution. If you want more information on this, there's tons of it out there. A lot of what I figured out on this comes from looking at YouTube videos, right? So there's a bunch of these that you can look at. This top one here is actually a link to a workshop that was presented at at the AAVSO annual meeting, which might have been the one you went to. Did you? Was it 2020 that you went to?
No, 2021.
Yeah, but anyway, they did this. They did a workshop there, and it's a little bit of a time commitment if you want to look at it. It's about 5.5 hours long. Goes through some of the test stuff. Goes through some of the Python things. But it's it's a wealth of information. It's run by this guy it was presented by this guy who's I think he's probably a professional astronomer, but he has a degree in law. Anyway, and it was a really interesting presentation that kind of shows you how to do some of this sort of stuff. These others are just other kind of hobbyist sites. If you want to know more about Python, there's, again, tons of sources out there for learning more about it as well. My favorite one is called Code Academy, I think. They're little short courses that you can take, and they're not free. They're 10 or $15 a piece. But what I would recommend is two things if you want to do that. First of all, I would try to avoid a Python short course that emphasizes data structures too much. A lot of them are more about kind of information management, how you would organize databases and things like that. So that's not the sort of thing you really need to do on this. You need to be more oriented toward computation. Then the second thing, and this is where the data mining is kind of going, if you're really ambitious and you want to do some machine learning stuff, that's where a lot of the action is in this right now. It's kind of automating this process so that you don't have to go through one at a time and look at these things, and you create learning tools that can recognize the things. So I think that's where a lot of this is going. So anyway, I'm pretty interested in this. If anybody else is and kind of wants to form a little interest group or something, I'd be very anxious to do that. But anyway, that's my talk.
So this is what you do if it's cloudy.
This is what you do if it's cloudy. or if you're just not, you just don't want to stay up all night.
Yeah.
This is the sort of thing you can do just, a little bit less of a time commitment, although I could see where it could begin to suck up amounts of time. Anyway, so thanks for your attention, and any questions?
Very cool.
Well, that took a lot of your time to learn how to do that, so I appreciate it.
Yeah, well, it was, it's really interesting, and right now with kind of telescopes offline, and it's so far to go to use them, it gives me a way to do some things.
So when you filtered that search and got 9 million, there didn't seem to be some sort of icon that says, hey, somebody's already done this one.
Yeah, there isn't, actually. That's why you have to go to that ExoMass site and
check ahead.
Check ahead to make sure that nobody's already found a plan. And there's other things you can use. You can use the test data to do variable stars. You can use it to do you can use Like or do astroseismology. The kind of little fluctuation stars kind of
Jiggle.
pulse and stuff. And it actually has data on that too. I didn't know that much about tests when I first started this, but it's a fascinating piece of equipment. One of the things I didn't realize is the aperture on it is super tiny.
Yeah, it's pretty small.
Not that big. Kepler was a pretty good sized mirror, basically. This thing's itty bitty, but
You mean the one on the satellite?
yeah.
The precursor to this was done ground-based, and it was multiple units spread around the world.
That transit search project.
Yes, right, exactly.
Yeah, I think wasn't Dennis one of the organizers of all
Could
that?
been, yeah.
I know he's
Connie.
written. The exoplanet course I took from ABVSO, he was the instructor,
Yeah.
and he wrote a lot of the little code tools that. I don't know what his background is, but he's obviously a pretty sharp guy. So.
Of course, one of the things with Kepler is they had no idea how many they were going to find. They found a few, and then I mean, you know, when you see how many were found and everything, and then it just goes up like that, they had no idea.
Yeah, and while Kepler looked at a really pretty small
Yep.
piece of the sky, it's amazing how big the test looked at. I didn't see if I can find one of these diagrams. Shoot, I'm not sure where to find it now, but let's do just TESS. Yeah, I'll probably get novels by Thomas Hardy. Yep, Test of the Dirt Wheels. All right, there we go. Let's look at this one. Shoot, I don't know. Somewhere there's a diagram of the piece of the sky that TESS sees, and it's quite large. You know, Kepler was a really small piece of the sky.
Yeah, wasn't TESS somewhere around, did it say it was constellation Cygnus?
It points at,
Because I was going to say that's where Kepler was. You know, it just started in that little doohickey there.
There's parts of the sky that are basically observed year-round. Other parts are only in the iris during particular quarters,
Yeah.
which is why you have to indicate that quarter thing out there, or else you might be looking for something that it wasn't pointed at that time. I don't know why. This one looks like interesting stuff, but not what I'm looking for. Shoot. Anyway, sorry. Oh, there we are. So there's the test pattern of search. So it's looking at pretty much looking at the whole shebang. And these little quarters are when it's pointed at these things, and then there's a particular area where it sees all the time. So it's kind of a scanner. It sort of pivots and then scans and pivots and scans.
And that was 4 years ago, it looks like.
Yeah. All right, so again, other questions?
Pretty technical, but may have some.
Yeah, I think if you're interested in doing this, and it's probably like any kind of research, there's a certain technical hurdle to clear, but it's not that much. And if any of you want this little script to play around with yourself,
It's learning Python first and then getting into this. That's
Yeah,
going to be
you gotta do
the
both.
big disadvantage for most of us.
I don't know how you feel, but the Astronomy League does their meetings, and they have people much like what you just presented.
Yeah.
So, if you want, I think we should, if you're interested, drop your name to Astro League and you do that presentation. You'd have to cut it down to maybe a 20-minute or 30-minute section, but that's pretty, you've done enough that I think people that, clubs that have very technical people in it might be interested.
Yeah, a lot of them are.
Astronomy League covers everybody, so.
Yeah, a lot of them are already probably going to know this stuff, to be honest with you. But
I don't know.
because I got a lot of this stuff just from these tutorials, right? I just copied and pasted. So
Nothing wrong with that.
I would not take credit for any of this. But yeah, if you guys if any of you want the script just to play with, I would be more than happy to ship it out there.
So I think they boot us out here in 3 minutes.
Oh, okay.
If I may switch gears, Mission Valley contacted me today, and they have like a day that they want to have someone at Farpoint on the 17th. So this is before our next board meeting. Instead of doing this via email, I thought I'd let you guys know. They're going to have stations, and and I don't know the grade levels, and I seriously doubt it's everybody, but this is an elementary school thing.